Alright, so the purpose of this video is just to explain counting on in thousands a little bit more clearly. So I wanted to start with a simple example, something that we all already understand, just to set the scene. So here's the number 20. If I want to count up from 20, and I want to count in ones, all I'm going to start by doing is changing the ones place. I'll end up with 21, so I'll have a 1 here, then 22, 23, 24, and so far the only thing that's going to be changing is the ones place. And I can do that all the way up until I get to 29. But once I hit 29, I can't put 2010. After the 9, we have to regroup. Now all I mean by that is that you can't have a 10 in one place. It becomes the next place over. Remember how we said to move from one place to the next, you multiply by 10? Well, that's because it takes 10 ones to make a 10. So once I have 10 ones, I just make a new 10. So this goes from being 29 to becoming 30. Because 10 ones is the same thing as having one more 10. So I would just add my 10 onto this and end up with 3 10s. Keeping that in mind, let's take it over behind the decimal point. So I'm going to come down a bit. Let me just start fresh. So we have a ones place, decimal point, tenths, hundredths, and thousandths. All right. Oh my goodness. I'm going to turn my paper to make it look like I drew that line straight when really I did not. All right. You gotta forgive me because I'm looking through the camera and that's why my hands are shaking too. All right, so let's pretend we have the number 4.72. All right, right now this number has 4 ones, 7 tenths, 2 hundredths, and no thousandths. Because there is nothing in the thousands place means that it has no value right now. So I could put a 0 there to hold that place, and my number has not actually changed. It's the exact same number. It's still 4 and 72 hundredths, because there is no value currently in the thousands place. If, though, I wanted to count up in thousandths, all I'm going to change is what is in that thousands place. So I'll go from having a 0 in the thousands place to having a 1, then a 2, then a 3, and so on, until I get to 9. Guess what's going to happen after 9? Well, same thing that happened up there. See how 29 became 30? Down here, I can still kind of see that 29. Or I could look at it as 729. Or I could look at it as 4,729. What comes after? 30. So once you have 9 thousandths, the next step, 10 thousandths, is really going to change your hundredths place. So I'll go from seeing a 29 to seeing a 30. So my new number will be 4.73. And I can put my 0 back in the thousands place if I want to. Because remember, a 0 at the end of this number, behind the decimal point, is just holding the space open. It doesn't have any value. So that's how I would count up in thousands. Let me show you how that would translate to a number line. All right, so I've placed 2 new numbers onto a number line, 6.84 and 6.85, and I've put them quite some distance apart. Those 2 numbers are actually really close together. 6.84 is not very far from 6.85. The difference is my hundredths place. So they're only 1/100th apart. That's a very small fraction. But even though they're only 1/100th apart, I can split the distance between them into 10 equal parts. If it's 10 equal parts, what am I splitting it into? Thousandths. Remember, we got our ones, decimal point, tenths, hundredths, and then thousandths. It takes 10 thousandths to make a hundredth. So if I split this into 10 equal jumps, to get me from 1/100th to the next, then it's going to be split into thousandths. So let me pause the camera and I'm going to split it into thousandths and then show you. All right, so I went ahead and split it into 10 equal parts. Now you might wonder to yourself when you look at the numbers like this, how on earth am I going to add up? Because after 4 comes 5, and the 5 is all the way over there, so my next jump can't be a 5. Remember what I said. Even though there is nothing currently in the thousands place, we can put a 0 there to hold it open. So when we look at it with a 0 there instead, I now see the number 40 and 50. I know how to jump from 40 to 50. 41, 42, 43, 44, 45, all the way up to 50. So I'm going to follow that pattern, changing my thousandths place as I jump. So this goes from 6.840 to 6.841, 6.842, 6.843, 6.844. Sorry, it's a little blurry. There we go. 6.845, 6.846, 6.847, 6.848, 6.849, 6.850 because it went from 49 to 50. Let's take a look at another pattern. Now this same number line appeared in your work yesterday, and I know it was a tough one, but let me break it down for you. It started at 4.1, 4 ones and 1/10, and goes to 4 ones and 2/10. So the difference is in the tenths place. Now, this wouldn't be so hard if it had 10 equal jumps for us, but they've only given us 1, 2, 3, 4 jumps. Even if I make this a 10 and this a 20 by sticking my zeros on the end, how do I jump 4 times to get from 10 to 20? It's a little tricky, isn't it? Well, remember, you can stick on as many zeros at the end as you want when it's after the decimal place. If I look at this as 100 and 200 by filling in my hundredths and thousandths place with zeros, just placeholders, makes it a whole lot easier for me to jump, because now I'm looking at it as 100 to 200. And I know how to jump equally in 4 equal jumps from 100 to 200. Remember what I said about quarters? 100, 125, 150, 175, 200. And all I do is put back the rest of my number, 4 point. Now, the thing with these number lines is that it just takes some practice and getting used to understanding how things work behind that decimal point. A key thing I really want you to take away from this video is that it does not matter how many zeros you put after the decimal point. They do not change the value of the number. It's not like when we're in front of the decimal point. Behind it is a completely different story. So 8.9 is the exact same thing as 8.90000000000, because these have no value. They're just holding open places at the end, and it really doesn't change the value of the number. It's still 8 and 9/10. All right, you guys, with all of that being said, I want you to try and find what number is shown by each arrow. So what's the number that goes with A and B and C and so on? You're going to need to look at the number lines, look at what's at the beginning, what's at the end, and how much I've split each line into. So this is 10 jumps, this is 10 jumps, but this is only 4 jumps. So obviously the jumps are going to be worth something different. So I'm going to hold this steady for a second. You can pause the video here, and I want you to write down your answers.